All right, well, here we are at the live stream. So, how are you guys all doing? I know we did a Zoom yesterday with second period, and that was pretty fun. And then today, third period will be getting together in the Zoom, and I can't wait to see you guys because it's just good to see each other every now and then. But let's see. Today's assignment was about solving for V, I, and R, and P. Oh, I don't know why, and power in these basic combination circuits. So it's a little bit of a jump from yesterday, and yesterday is really what you need to mostly focus on. So if you were okay with that, then you're probably pretty good. If you're here, say hi, by the way, so I know somebody's here. Otherwise, I'm gonna have to send out a remind and and let you know. But in fact, let me just do that right now. I know some people were talking about showing up today, so let me just do that right now. Live on the screen. So second period, third period. I think everybody forgot, and that's okay. Now. All right. Well, messages sent. I know some of you guys are talking about you were going to pop in so I could explain some things, and I will do that. But let's see. Practice 7, practice 6. I'll just wait a minute. Maybe something's wrong with the chat. Usually it's not this dead in here. Oh no, error occurred. Uh-oh. Am I live streaming, Aiden? I seem to be having errors. Hello. How are you doing, Noel? All right, cool. Well, then I'm just going to continue on. And hello, Mr. Zorn. All right, cool. So, all right. Practice 6. Now, I don't remember, a couple of you guys asked me some questions, and let me see if I go back to remind and see if I can remember what questions. But if you could just remind me, let's see, practice 7, number 1 and 3. Awesome. So let me get number 7 opened up. And question number 1, let me just do a little copy of this, and then I'll paste it into the thing, and then I'll be able to solve it for you. Oh, that's right. Aiden knows Mr. Zorn. And I mean, who doesn't know Mr. Zorn? All right. So, and of course, let me just change this to not red, because I don't know why it always defaults to red. All right. So practice 1, this is, or practice question number 1 on practice 7 is, let's see, this is practice 7. So like I said in my videos, the thing I like to do is a couple things. There's a couple, like, I don't know if I'd call them steps, but just things to keep in mind with these things. And the first thing I like to do is have the Ohm's law equations handy. So I is equal to V over R is one of them. V is equal to I times R is another one. And the third one is going to be R is equal to V over I. Okay, and then there, of course, is power. P equals I times R. So, Mr. Zorn, crashing our little party here. All right, so I've got the Ohm's law equations handy so that I can have them, and of course I'm going to have to get my calculator handy because I'm going to need those. Now the first thing I want to do is the givens. So what are given to me? What are the givens here? And the givens, of course, are the 60 volts across the battery. So that is going to be the V total or the V initial, and so I'm going to write that right there. Then I have our 1 ohm. So I just like to typically go clockwise when I'm labeling these things. If you go the other way, it'll just be in the opposite order, and that's fine. but my first resistor is 1 ohms. So I'm just going to mark that right here. And then going clockwise, I come to this little mess here. And typically with parallel circuits, now I'm just going to tell you, this is a difficult one, of course. It's practice 7. I mean, when you get to this point, they're just hard. And so you just, but once you start working through it, you get used to like the processes. It's just like solving any other puzzle. You know, you solve the outside part first, and then you work on the inside. You do the stuff that all looks the same color, and you start to kind of get like the pattern of it and understand like what works and what doesn't work. So when you get to something like this and you see that, well, it's not a simple circuit anymore. In fact, this part here is wired in parallel. And so what I'm going to do is I went around clockwise, and I'm just going to go left to right now. So it doesn't really matter. I'm just labeling things now. And so 12 ohms, 4 ohms is probably my next one, and 8 ohms. And wow, jerk. And 5 ohms will be my last one, just going in order here. Now, that's it. That's all my givens. So what I usually do, like givens is the first thing I look for. Any givens. That's done. We're done with the givens. The next thing I look for is what I call, and this is just Mr. Jern calling the easies. Okay. And the easies, oh, I know. Again, I was wondering why everything sounded so funny. It's because I'm wearing my headset because I was just in a meeting, and wow, okay, this makes things a lot better for me. No more headphones. So the easies are just what do we know based on the rules of circuits. Okay, we know that in a series circuit, the current everywhere is the current anywhere. So if you know the current anywhere, you know the current everywhere. Now we don't know the current anywhere, so we can't even begin to look at that. In a parallel circuit, we know that the voltage drop across any one branch will be the same as all the other branches if they're wired in parallel. We don't know that either. So then, since we can't take care of any quote-unquote easies, I look for calculations. Calculate. Almost. All right. Well, I could calculate the total resistance here. All right, now it's going to take some doing because we have sort of a complicated circuit, but that's okay. So with resistance, I want to, okay, good. Well, I will re-explain the voltage drop when I get to that part of the circuit. So that is a phenomenal question. And so I will hold that right here, and I'll explain it once I'm at that point. So right now though, I need to look and see what am I doing with this circuit. It's a big mess, okay? And like I said yesterday in other videos explaining this, I want to work my way from the inside out. So what do I mean by that? Well, if you look at this giant circuit here, this is basically a series circuit. And within that series circuit, I have this branching part. So I have a parallel resistors in a series circuit. But then within this branch, I have another series circuit. So I have a series within a parallel within a series. So pretty confusing, but if you just think of it that way, it's a little bit easier. So I got this series circuit right here. This is my most inward part, and I could pretty much look at this. I got 4 and 8, and they're right next to each other. So right away, I could just take 4 and 8, since they're wired in parallel, they're wired right next to each other, and I could just add them together. So in other words, these two resistors right here have an equivalence of 12 ohms of resistance, 4 plus 8. That's it. Okay, so that is this entire branch of this parallel circuit right here is an equivalence of 12 ohms of resistance. But compared to the other branch now, what's going to be the total for this whole part right here, this whole entire parallel thing? Well, now I've got basically the equivalence of a 12 ohm resistor and another 12 ohm resistor. So what do I do with that? Well, that's the thing where I had to go 1 over 12 plus 1 over 12. I had to take the inverse of the resistances and add them together. Now, since I don't like to deal with fractions too much, I'm going to use my calculator like I deal with all the time, and I'm going to just take the inverse of 12 plus the inverse of 12. I'm going to put that into my calculator, inverse 12, 12 inverse, and that comes out to 0.167, blah, blah, blah. Okay. And I'm immediately just going to take the inverse of that, because you got to take the inverse of your answer. And it turns out that the equivalent resistance of this whole part right here is 6 ohms. Okay. So the 4 and the 8 working together are going to be causing 12 ohms of resistance. Because of the branching nature of these two right here, because they're in parallel with each other, you did what we did down here. You add them up like that, and you find out that this particular section is 6 ohms of resistance. So once again, I'm just working my way from the inside out. So now I have a 6 ohm resistor. This whole thing counts as a 6 ohm resistor. And we start to realize, oh, that's in series with this 1 ohm resistor, this 5 ohm resistor. And so now we can just add these up. 5, let's see, well, let's go in the order from above. So 1 ohm plus 6 ohms plus 5 ohms is going to give us a total of 12 ohms of resistance. So the total resistance is going to be 12 ohms. Okay, I'm going to pause there. I'm going to see if there's any questions about what I just did there. I'm going to take a little sippy sip. Okay, good. Because if you could get that, honestly, that is a big chunk of things to understand there. Okay, and it's probably a little bit more complicated than you'll actually need to know, but that's okay, because I mean, if you've ever been in a sport, you know that you should practice harder than you will work for at the game. That way, when the game comes along, it'll seem a lot easier. So we're going to do this, we're going to do these practices, and then when the actual game comes along, you might find it's a little bit easier than what these are. You can't just add them up because of the way that resistors work when they're wired in parallel. See, don't forget, when things are wired in parallel, no matter what the resistance you add in parallel, it's another pathway to follow, you know? I mean, think about it. You head down to, okay, I'll get to, you head down across the bridge to the T&I building, right? There's just one bridge, and it's super crowded. Even if they added another pathway that to get to the T&I building that only you could walk single file down, even though that pathway is single file and that would be super crowded, it would still overall, like those, it would still alleviate the crowdedness of the main bridge, because now at least some people can go across through the single file line. So overall, the overall resistance has been lowered because you added another pathway. So that's why you can't just add resistors together like that. That's how you do the so you got to do that. I can't put it up right now, but that's why adding things in parallel are so different than adding them in series. So how did I get 6? You always add up the 4 and that. Yes, so the 4 and the 8, on the other hand, are right after each other. They are, in fact, let me just erase this a little bit just so it's a little bit more clear. The 4 and the 8 are right at one after another. So like imagine you're going down a hallway. You don't have additional pathways to follow. Everybody has to go through the 4, and then everybody also has to go through the 8. So everybody's going to get slowed down at the 4, and then they're going to get slowed down at the 8. It's just more resistance that you have to go through, and so it like adds up directly. So you just add the 4 and the 8 together. That's why you just add the 4 and the 8 together, because they are in series with each other, just like 2 choke points would be in series with each other. 2 stop signs driving down the road, you have to stop at both. If you have to stop at both, then that's going to slow all the cars down. But if you have 2 different pathways, 2 different roads where you only have to stop at one but not the other, that's going to speed things up. So in short, and this goes back to practice, what was it, 4, 3, when we talked about resistance, when they're in series, when they're right after each other, you just add them up. Okay, 4 plus 8 gives us 12. But when they're in parallel with each other, when you have the alternate pathways, when you have the choices, then you have to do the inverses. And that brings us back to Angelina's question. Okay, So we had the 4 and the 8 together acting as a 12 ohm resistor because they're working together, because they're right after each other. All those electrons have to go through both. But because there was this split right here where the electrons can go either way, well, then you had to add up the resistors like you would a little bit differently, because when they're in parallel like this, you have to go and add them up. And basically, to sum it up, when you have them in parallel, you have to take the inverse of the sum of the inverses. So what I would do, I'm going to start this over, is it's 1 over 12 because of this 12 ohm resistor right here. So the inverse of 12 plus the inverse of 12 because this branch is 12. Okay, 12 ohms resistance like we just got. When you add those together, you get 2 over 12. Okay. But then you have to take the inverse of the sum of the inverses. So you flip that. I don't know if there's a mathematical sign for that. So now you got 12 over 2. And that brings us to our 6 ohms of resistance. Okay. I put it in the calculator because not oftentimes are the fractions going to work out that nicely. But inverse 12, inverse 12, and then you get the answer. And then you just take the inverse of the answer and you get 6 as your answer. Okay, so that's how I got the 6 and the 12. Excuse me. Okay. I'll go back to that. So if you got a question, you're just kind of processing now, type it in there. I could definitely go back to that. All right, now you know why this is kind of a difficult one. It's practice 7, all right? Practice 7. All right, so I filled in another box. We're done with the givens. There's no more givens. So I'm going to look for easies. Do I know the voltage across one branch? No, I don't know any voltages yet except for the total. Do I know I don't know anything yet. Nothing's happened. So I could still do some calculations. So current here, I got the voltage, I got the resistance. Whenever you got 2 out of the 3 boxes, you could solve for the third box. Just lickety split. Okay, current is going to be V divided by R. So I will take the 60 divided by 12. And I should definitely know that, but I'm going to check to just make sure it's 4. And 60 divided by 12, 60 divided by 12. See, good thing I checked. Is 5. I actually did know that, but I'm kind of in a, well, whatever. So 60 divided by 12 is 5. And here, let me put my little arrows just to show the direction we went. So basically, we had all these, and we summed them up to be 12 using the rules of resistors. Then once we got that, I was able to calculate the 5 amps. All right. Now what? Well, we'll go back and look for easies. Are there any easies? We know the current going through the battery, the total, the batteries is 5 amps. And so we start to think, well, okay, easies means the rules of circuits. In a series circuit, if you know the current anywhere, you know the current everywhere. Well, along with, in series with the battery is going to be this 1 ohm resistor. So that means all those 5 amps are also going to go through the 5 ohm resistor, or the 1 ohm resistor. So I could use that to know that. Then I could imagine it. So current is the flow of electrons. So those electrons, it's going to be 5 amps worth of them. And those electrons are going to come here and they're going to be split up. Now, I don't know how they're going to be split up. I have an idea. I suspect because they're both 12, it's going to be even, but we'll come back to that. But regardless, what's going to happen here is those split up 5 amps come back together, and guess how much current goes through this 5 ohm resistor? If you said 5 amps, you are correct. So I'm going to come down here and I'm going to say 5 amps again, because then those 5 amps continues back through the battery and around and around and around. So we were able to use those so-called easies, in other words, knowing the rules of circuits, to figure out 2 more blinks, which was kind of nice, because now you can kind of see what's going to happen here. So we'll come back to this whole mess in a second, but does everybody understand why it's 5 amps in these 2 locations? Let me know. All right, So knowing that, you could probably guess what we have to do next. Is now we have 2 out of the 3 for in two spots. So voltage, well, I look at my little thing, is just multiply current times resistance. So 5 times 1 is nice and easy. That's a 5 volts. And 5 times 5 is another kind of easy one. I could do that in my head. Is 5 volts. Okay, so I was able to calculate those and just showing my arrows to show the direction of our thought process. All right, now what? Well, this is where you might have gotten stuck, especially if you don't understand the voltage drop thing yet. Okay, current is the flow of electrons. Now, why do things flow? Why does water flow? Water flows because you have a high point. And so like a hill, like, so here's a little, I don't know, there's a little hill. Whoa. And where does water flow? Well, water flows down. Why does water flow down? Because of gravity. What direction does anything flow? It flows down. It always flows from high to low. And that means whether you're talking about gravity and water, or you're talking about electric potential energy and electrons. So this battery raises it up to 60 volts of electrical energy. Well, if you got electrical energy and we got a bunch of electrons all crammed together and they don't like each other, they're repelling each other, what are they going to do? They're going to flow away from each other until the energy is dissipated, until you basically have equivalent of no energy, okay, until they're not pushing against each other as much as they were. And so the analogy I always use for battery is like the elevator that brings you up to the top of a building or whatever. So this battery brings them up 60 volts, okay? Brings them up 60 flights of stairs, 60 stories, whatever you want to call it. And now what happens? Well, at this first resistor, it's going to drop. The voltage is going to drop. The voltage is going to be some negative number. It's going to drop how much? Well, we actually already know that. We just figured it out. Oop, this one. It's going to drop 5 volts. And I just put the negative there just to kind of help us with the analogy. We're losing 5 volts because we're gaining the 60 volts here. And we're losing 5 volts right here. All right. And we're going to lose a nut. Well, now we're going to get what is going on here, Mr. Jern. Well, okay. So you walk down the hall, you're at 60 stories tall. You go down these stairs right here. Now you're at 55. Okay. You get to this point, little hallway turns around, and then the hallway splits. And if you think about it, just like at school, there's a lot of different stairwells you could go. You could keep going down a hallway. You could turn left. You could turn right. Either way, you're going to come to some stairs. And when you go down these stairs from here to here is going to be some drop. Now, we don't know what it is yet. But we do know that from here to here is another drop. Good question, Noel. And so why is it -5? Well, because where'd it go? Because we calculated that right here. Are you asking why it's negative? Because I'll tell you why that in a second. But the reason it's 5 is because of, well, just the calculations. Voltage is current times resistance. And so we were able to figure out that the voltage drop is going to be 5 because the current is 5 and the resistance is 1. Now, why is it negative? I was using it. It is negative, but it's just to help us understand what's happening. It was raised up 60, and now it's losing 5 volts of potential energy, basically. It's just like the hill. If you got a hill, here, let me redraw our hill. Maybe this will help, maybe it won't. Okay. Right now, we have a hill, and that hill starts up a certain thing. We're going to call it 60 meters tall, okay? That hill's going to drop 5 meters, okay? And that's going to be this drop right here. And then it's going to drop another amount. And it's kind of funny because just like with a lot of rivers falling downhill, sometimes it splits off. And so the water can go down this way or the water can go down this way. Okay, and that's going to be this section right here. In fact, if it goes down a certain way, it's going to be a little bit different. It's going to look like this. It's going to go down. It's going to do this, and then it's going to come down again. It's going to drop a little, and it's going to drop a little bit more. But then the water gets to another certain point, and it drops the rest of the way till it's like basically ground level. And that's going to be this resistor down here. And then somewhere there's some sort of a pump. Remember, the battery is a pump? So some sort of, okay, good question, Angelina. So there's some sort of pump that's pumping the water back up to the top of the hill, and that's our battery, raising it up 60 volts. Okay. And we know that at this last drop, well, how much is it dropping? How do we find? All right, we're getting there. We're getting there. So we already calculated. That's a good question. It's a good question. So we already calculated this first drop is 5. And we already know the last drop is also calculated for us. Well, we did it, is 25, because we knew that the resistance for that last one is 5 ohms. We know that the current there is 5 amps, and 5 times 5 is 25. So we know that this right here is going to be another negative 25 volts. Okay, so we could say, so my drawing is horribly out of scale. So this is going to be a negative 25 volts right here. Okay. So that is what voltage is. So this is going to be, I put volts, this is going to be meters because this is a waterfall analogy. So this is some sort of pump that's going to be pumping water back up to the top. All right. So if the water started out 60 meters high and it dropped down 5 meters here and it dropped down 25 meters here at the end, how much did it drop right here? So if you got 30, you're correct. So right here, the whole drop is going to be 30, I guess, meters in our little analogy here. Probably shouldn't draw that. All right, so it's a negative 30 drop right here in the middle. In other words, from here, it's going to drop 30. Now drop, what do you mean drop, mister? Remember, it's like, why does water flow? Because it starts out high and it flows downhill because of gravity. Why do electrons flow? Because you have a battery that basically lifts it up. Instead of lifting up against gravity, it just lifts it up in a different way. It just increases, instead of gravitational potential energy, it's got that electric potential energy, the energy of those electrons being smushed together and repelling each other like rubber balls being smushed together. Okay, so it's a different kind of energy that it's lifting them up. Okay, all right. Point is, even if you don't follow the analogy, that's okay, because you could still work this through knowing that if we started out at 60 and we lost 5 volts from here to here at this resistor, and we lost another 25 volts across this resistor, well, then we know that from this point to this point, we lost another 30 volts. All right. Now, that means from this, okay, now going back to our analogy again, with the stairwell, if you went to the left, let me get rid of these circles because they're kind of crowding us here. If you went to the left, how many stairs do you have to go down? How many stairwells do you have to go down to get down to this 30 drop? Well, that means that if you think about it, there's only one stairwell you have to go down, and that stairwell will take you down 30. So for the 12 ohm resistor, the voltage drop is 30 volts. None I'm aware of at this point. That's why it's a puzzle, and you have to puzzle it out. All right. Now, that said, don't despair if you don't quite get this, because like I said, this is going to be harder than anything I'm going to expect you to actually do on a test. Originally, this was going to be on our tests, but we're going to kind of, you're not going to be expected to be able to do this kind of level of difficulty. All right. So that said, doing this level of difficulty is going to help you tremendously with doing the other stuff. Practice 5 and 4 especially, maybe even practice 6. Okay, so no, Angelina, there's not. It's a logical puzzle. All right, so what that leaves us with, oh, let's just pause there because we got another box, and now we have another empty box. We got a one we could do now. We got 2 of the 3. So current is going to be V divided by R. How did I get 30? Though it's just a negative 5. Let me just make sure I did this math right, because I started out with 60, right? And I'm getting, apparently I can't write that. So let me just scooch that over. So I started out with the 60 from the battery, okay? I lost 5 up here. So that brings me down to 55, okay? And then I'm gonna lose, I don't know how much there, and then I'm gonna lose 25 there. So 5 minus 5 is 0. 5 minus 2 is 30. So that leaves me with 30 for this part right here. All right. That's how I got that. How did you get 30? It's just, I see what we did. No, Angelina, it's subtracting those from the starting amount of voltage, the 60. Okay. So that's important. You got to subtract. Don't just add those together. Good. All right, cool. All right, so just like a puzzle, sometimes if you walk away, it makes sense. Sometimes if you walk away in the middle of, you're like, what was I doing? I don't remember. I had some logic going on here. Okay, so back to this. We have 2 of the 3 boxes, and I'm going to calculate this current right here. So now that I was able to figure out that this is going to be 30 volts. And so now I'm going to be able to calculate this current, and current is V divided by R, so 30 divided by 12. That one I just want to do a double check. It's going to be a decimal number, yeah, 2.5. So it's going to be 2.5 amps. Okay. Well, see how it's a puzzle. So now you had to start to think. I know from here to here it's going to be 30, but somehow that 30 gets broken up. You know, is it going to be 15 and 15? Is it going to be 10 and 20? How's it going to break up? Well, we don't know. So we have to figure out something else. What did we just learn though? We just learned that there's going to be 2.5 amps going this direction of current. So if there's 2.5 amps going in this direction, and we started out with 5 amps coming in, well then how many amps is left over to go to the right? Well, I guess that means there's 2.5 amps that's going to go this direction. All right. So that is, I don't know if that's, I don't know what you call that, calculation, easy. I don't know. I'm just kind of like puzzling this out now. So because we know that there's 2.5 amps going in to the left, that leaves us with, we started with 5 amps, 2.5 amps going this way. And since 2.5 amps goes to the 4 ohm resistor, 2.5 amps has to go through the 8 ohm resistor. And so it's going to be the same. Okay. And now you could probably finish it off, but I'll finish it off with you or for you. So V equals I times R. So 2.5 times 4. Just to double check because I don't trust myself with these things. Maybe 10. And well, 2.5 times 8 then will give me 20 volts. So now we know that it's going to drop 10 and then 20 volts to add up to that 30 that we talked about earlier. Confusing? Absolutely. Doable? Barely, we'll call it. So it's just logic and being familiar with what is going on there. Once you figure out the resistance, that's the first door. That's the first Horcrux you had to defeat. Okay. And then there's still a couple more. Then good thing that I mean, I'll probably have a question like this on the quiz, but on any test or whatever. I want to see how you can do on these things, but don't worry about it. Just take your time. We got nothing but time with these things. Uh-oh, my Zoom meeting is supposed to be starting. I might have to put that off. But well, let's see. Should have counted on this taking a little bit longer. Isn't it though? It is weird. It is weird. And that's why I am sad that I'm not there to like help you out. You know? So yeah. All right, is there anything else I could do? there anything else I could do for you right now? You're already on the Zoom. Is anybody else there? I'm kind of there, but I don't think I could split my microphone. All right, tell you what, I'm going to end the live stream then. See how you could do with the next one. If you still want me to do another one, there's no new practices tomorrow. So if you want me to do another practice question, if you want me to do another practice question, I will tomorrow. How about? All right. If there's anything else you want me to explain in the meantime, then just send a remind. All right. Looking forward to seeing you guys in third period. It was great to see you guys second period yesterday, I gotta tell you. So, all right. You guys take care of yourselves and let me know if I could do anything for you. Bye.